how long are those links going to be up on the website?
Well, months and months, probably. Yeah.
Yeah. I want to eventually save them, but I just haven't had time to go and save them on.
All right. Yeah, let's say a month at least, probably more.
So I can do it fine.
Yep. Hey, everybody, how's it going today? Thank you for joining us. So glad that you're interested in learning more about the Challis Magmas. The local time is 12:47, I think, 12:46, whatever, dealer's choice. And we will begin our program at the top of the hour, as per usual, at 1 o'clock. So that's a little more than 10 minutes from now. It is hot outside, and we have everybody dressed in shorts and sun. Emma's rocking some kind of beach attire with her hat. Matthew, Tim, Ariel, got 4 in the room. Let's say hi to a few folks here. I was bugged by my crackling microphone again last time, so I think my trick is to have a little bit of slack here. I think I was taught, and I think that's the issue, but I mean, how long have I been doing this? More than a year. I'm still learning. So, where are you viewing from? Can I say hi to you? Are we crackling again today? Hello, Minnesota. Saubers, last day in Ellensburg. Jacksonville, magma-free Florida. Good one, Larry. The New River Valley. Odense, Denmark. Maryland. Bergen, Norway. Winnipeg, Manitoba. Northern Virginia. Ireland. Harlan. Beautiful downtown Harlan, Iowa. Notre Dame, Indiana. Shake down the thunder. Newport, Oregon. Northwestern England. I got to get my eyes down here. Things are scrolling off the screen. I'm just catching them before they disappear. Too much information. United Kingdom. Tasmania. Hello, Bryce. Oxford, UK. Los Angeles. Spokane. Germany. Camino Island. Lake Oswego. That's in the Portland area. Jennifer's from Boise. Boulder Creek, California. Portsmouth, UK, Southern Oregon, Duncan, Oklahoma, I down to the bottom. Italy, hello, Stefano. Nordland, Washington. Mike, I don't know where that is. Is that over on the coast somewhere? Andy's at the Mima Mounds, Maltby, Happy Valley, Oregon, is present today. Richland, Washington, Mardine. Napa, California. San Jose, Darrington, San Diego, California, Dayton, Ohio, San Diego, California, again, Okanagan, BC. Hey, man, I heard the borders maybe are going to open up in a month. Did you hear that too? If so, I think we're heading your way. In the inland British Columbia this summer sometime, hoping to do that with my family, but who knows. So I guess we're doing okay, huh? Cracking today. Sounds like clipping from too much level before digitize. Okay, I'm a little amped, I gotta say. No pun intended. This one may work, but I'm not sure. But I hate that crackling microphone. So I just lowered myself down a little bit. I've got a bunch of extra play here in the wire. Can I just pause? Yes or no? Do we still have a crackling microphone? Yes or no? Crackling microphone, yes. Crackling microphone, no. Can you help me out, please? Yes or no? Delay in the comments. You have 2 words, no or yes. That's good. That's a lot of no's. That's a lot of rejection, but I understand. This is the question that I asked. Okay, all right. All right, thank you. Thank you. All right, haven't sworn yet. That's a good sign. It's early. So I can't resist holding this up again and say thanks to the gentleman in Colorado. We will be having the students, by we, I guess me and Bijou will be hosting the students in our backyard on Thursday after class, and we will be sampling. We will be draining this bottle between the legal people available in the backyard. So totally on the up and up, but looking forward to that. Got some announcements to the students about what's happening tomorrow. We're heading over to Wenatchee, rendezvousing, that's French, with Jeff Tepper, collecting some Challis rocks, and filming the whole kit and caboodle. Also visiting earlier tomorrow morning in Wenatchee with Tom, who is as I understand it, retired geologist from the Cannon mine, the gold mine at Wenatchee. So I've already forgotten who tipped me off to Tom, but thank you for being a viewer and tipping me off. So I've got a full day scheduled for tomorrow. And if I get a text from a couple of the boys up at First Creek after class, I'm going to bust up there and visit with a guy who has a blue agate mining claim. So there's lots going on here, despite the unseasonably hot temperatures this week here in Ellensburg. Okay, a couple thank yous today. Wait, where's the note? Cache Creek North. Cache Creek North. Hey man, Cache Creek North, I don't know if you're a male or a female, doesn't matter. A person in, I think, Yukon territories, if I'm not mistaken, Cache Creek North has sent my favorite, strawberry, rhubarb, custard, danishes. We have one box, so there's 12. Pretty sure also from Cache Creek North, another 12 or 13, that'd be a baker's dozen of strawberry, rhubarb, custard danishes for the students. Emma brought napkins. And Sam Clindworth, son of owner Jeff, and Sam does all the early morning baking with Nick. Sam made a special delivery for an assortment of sticky bun, bear claw, stuff I can't pronounce, downtowner, pain de chocolat. Emma, you still have the chocolate? Yours? Yes. This is Emma's. Early bird gets the worm. So these are supposed to go to the faculty, courtesy of Jeff and Sam Clindworth at Vinman's Bakery. We'll give them some danishes, but the students get their pick first. Students are more important. We all know that, don't we? Okay, so time to feed the chicken. Here we go. Nobody touches the chocolate one, that's Emma's. Thank you, Luke, for playing by the rules. What'd you say, Rylan? Oh, the bingo. It's already going? Bryce, are you drinking? Please come and eat some food. Everybody's looking at you, Bryce. Why? Oh, Jesus, it's here. Can I share this? Oh, boy. They have passed out. Who did this? Bryce, did you do this? Bryce, listen to my words. Did you do this? No. Thank you. Emma, very creative. I should somehow include this in the final exam. I don't know how would I do that? Supply grain alcohol while you're taking your final exam. I would be fired by, there's so many reasons I would be fired. Emma is the creator of this, probably co-pilot Bryce.
I'm glad I only eat half my salad 70/50.
That's right, Rachel. We have one handout today, young people. One handout. Very colorful. Hope I get there. Colton, good on. Megan, hello.
Hello.
Rachel, hello. All right, good, good, good. We have some happy people. They are eating, smiling, nibbling. I guess I'm going to go visit with folks. Don't take it personally.
No grammar whatsoever, just like.
Microphone thing always ticks me off when I see that. So I'm glad we have a functioning microphone at the moment. Yeah, it's just a programming note, I guess, and then I'm going to go visit for a second. We got a lot of great energy in the room. That's probably on the bingo card. I know it is. This is it, man. Today and Thursday, that's it for the live streams. And I don't know the next time I'll live stream from this classroom. It might be years. I really don't know. But I will talk on Thursday about what I have in mind for this summer, but there's no schedule, of course. I've got some plans, but nothing rigid. But for this 351 class, I trust that many of you have been with us the whole quarter. We started in late March. And so this week you can look for today's live stream, Thursday's live stream. I recorded a Zoom chat with Jeff Tepper yesterday, so I'll put that on my YouTube channel and probably give it a number, like, I don't know, episode 31 or something is Jeff Tepper by Zoom. And then I'll be filming tomorrow in the field over at Wenatchee. So this week there's 2 live streams and there's 2 pre-recorded videos, and then that'll be it for the class. These guys are taking the final exam next week, but you will not be involved. All right. All right. Food. Colored handouts. Got most everybody. Business-like vibe. You did not go home because you were home the previous weekend, but Emma went home. Was it a lonely 4 days of nothing?
You know, when I'm not in town, you just sit there and just cry.
Yeah. Bryce, you just cry in your dorm room?
You said I was crying.
You go to Costco to get Kleenex or something? It's like a huge pallet full of Kleenex and then just sob in the corner?
I was rejoicing. I was like,
Tim. Logan.
Be here tomorrow morning.
Okay. Good afternoon, everybody. I'm very excited about today's session. I have plans. It's a Tuesday, but I think I have an actual rigid plan. And the goal that I have is to make it to the end of the plan today, because we do have one more lecture this Thursday. And if I do this properly today, I will have things perfectly set up for our detailed Jeff Tepper tectonic model discussion on Thursday. So I'm kind of all business. I want to get to that, but I do have a few quick announcements. You saw my email yesterday, correct? Email yesterday had details about tomorrow. I can't promise the best time ever. I've never been up there. there's other variables involved. We're meeting with Jeff Tepper in person. We're meeting with Ralph Dawes in person. They may or may not have a handful of students with them. They've got work that they're doing, but I've asked for us to tag along, hike/collect/interact/whatever. A lot of slashing. What? I don't know. So it will be an intense day, at least for the driving. I have to get way up there on that dusty road. I've never been up there. So what I've put in the email is what I have. With all that said, and plus 90 plus degree temperature Fahrenheit, how many are thinking they're coming tomorrow? Oh my God, almost every year? Oh wow, that's great. That's so great. I figure it's an extra long drive and late in the quarter and everything else, but that's wonderful. That makes me happy. So I will be meeting you at the secret spot at the secret time, and we will just improvise as I discussed in the email. And I genuinely hope it's a memorable day for all of us. So that's tomorrow. Thursday's our last lecture. A week from Thursday, 2 o'clock, that was in the email, final exam. I got nothing to say about the final. It's identical in format to the midterm. It's the same approach. If you were required to read a paper, you're responsible to write about the paper on the exam. We're not doing any more required reading. There are no more asterisks. There's a bunch of new papers this week. You're not required to read them at all. You got other stuff going on. You're certainly welcome to, of course. I'll refer to them, but there's nothing to say about the final exam except that what you saw and experienced on the midterm is coming at you second half of the class. Any questions? I want to get rolling. Hayden's here. Let's do this. Okay? Let's do this. So what is the plan? Blame it on Silesia. Let's not forget that the accretion of Silesia is the reason, timing-wise at least, for the Challis Magmas. But of course, it's been a long weekend, a holiday weekend, so I have to get us back into where we left off last time and get those juices flowing again. But that's our first goal, is to put the accretion of Silesia into this story. Then I take what I learned from Jeff Tepper yesterday. I had a Zoom chat with him. I recorded it, got his permission to record it. I'll post it sometime this week. I'm not sure when. And he has all sorts of detail with geochem that I kind of half understood. I admitted it at the time. I was like, I love cats, Jeff. He's like, what? Focus on what I'm saying. It's like, okay. So that's there as a complement to what I'll try to do with you here, but it involves the upper mantle. Once we realize we need the mantle upwelling and triggering the formation of these Challis magmas, then we start brainstorming. But it's not an open-ended thing. I do have a plan. So let's be kind of semi-linear about it. Did the Yellowstone Hot Spot exist ever during this time to create the Challis Magmas here in the Pacific Northwest? Yes or no? Then we'll move on to, do we think that spreading ridge, the famous slab window and the subducting slab, divergent plate boundary, is that the main story for what's beneath the Pacific Northwest during Challis time to create the Challis Magmas? And then I'm, again, hoping to finish, but if I don't quite get there, we'll start next time with this major discovery, a tomography, a seismic tomography major discovery about 10 years ago, something called a slab curtain. And that's going to get us into Jeff's specific model. So Jeff's specific model is not on this board. We're going to look at his data again. He's the kind of catalyst for this whole discussion, but we're not getting to his details until Thursday. So Ryan's going to be pissed again. Oh, well. What else is new? So what's first on the docket? A reminder in a very simplified case. Remember, our boards were real messy last time with colored chalk and everything else. I think I want to simplify the best I can. This was the bomb that I dropped with you late last time. You remember. We have these Challis magmas between 52 and 44 million years old, not just in Washington, not just plutonic rock, but volcanic rocks as well. Do you remember BADR? We got everything but the kitchen sink, silica content-wise, making up the Challis magmas. Many of you are nodding your head. You remember this now. We have diverse magmas. In hand sample, they look just like the Cascade Volcanic Arc or the Idaho Volcanic Arc. And we said it's more than just a Washington story. these Challis Magmas, I'm reminding you now, just trying to get you back in the flow. British Columbia, Oregon, Idaho, Montana, Wyoming, even back in the Dakotas, right? A regional story. We're only looking at a portion of it. However, before we quit, we had this very specific, and this is Jeff. This is Jeff's major contribution to this Challis research. New stuff now. Jeff has looked at 30 different rock suites over 20 years. Professor, students, undergraduate research. They go out, they bang on some rocks, they bring them back, they analyze them geochemically, they get a detailed uranium lead date. He's got 30 of those suites between Idaho and the coast. And we will eventually, especially on Thursday, come up with Jeff's very specific tectonic model to explain this age pattern. This age sweep, as we called it last time, starting in the northeast part of Washington, 52 million years ago, and these Challis magmas get younger and younger and younger and younger, generally, until about 44 million years ago. It's coming back to you now. You've got it now. Okay, let's leave that. Still kind of half reviewing and half tossing in some new stuff. Yeah, here. So this is kind of a cleaned up version of what I was doing last time, but I'm going to add Selexia now to make sure we can see, before we get into details of tectonic models, how we can bring Selexia in. So this is a plate tectonic cross-section. This is a map of the same area. I'm not using colored chalk now, but I had that last time, remember? Idaho arc, volcanic arc, rocks that are older than 52 million years old, all sorts of geochemical indicators that this is an old volcanic arc. Therefore, we have a trench. That's what I have in dashed here, like coming through like, I don't know, Walla Walla or something. This is older than 52 million years ago. We don't have Selexia yet. And we have open ocean, subduction at the trench. So this here is this. This here, classic picture of a convergent oceanic versus continental plate boundary with volcanic arcs, stratovolcanoes, blah, 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 subduction generated melts in this Idaho arc. But we don't have that anymore. There are no volcanoes in Idaho. So we're going to kill the Idaho arc. And we're going to jump the trench. Now that's a phrase I've used in my teaching before, and it's kind of a misleading statement, jump the trench. Let me explain what I mean by jump the trench, and then let me put a modifier on it. Let's use an average number of 150 miles, a nice round number, 150 miles between the position of an oceanic trench and the volcanic arc that's inland, 150 miles. So here's our trench arc, 150-mile distance. Do we have that today? We do not. I'm going to modify this now, okay? Today, we don't have the volcanoes in Idaho anymore. We still have the plutonic rocks. That's the Idaho batholith. Do you need me to do this? I'll do it. Volcanoes are away. We killed it. We killed the arc. And the story goes that starting 44 million years ago, our trench gets shut up in its present position offshore. And we have our Cascade arc dominating the Pacific Northwest since 44 million years ago. So somehow I'm going to put the trench out here. And 150 miles inland of this new trench position, I'm going to put the Cascade volcanoes. I'm like, what's he doing? It's like an incomplete sketch. Well, you know what I'm doing. Why did we jump the position of our trench and therefore jump the position of our active volcanic arc? We added Siletzia. The accretion of Siletzia is the main reason that we kill the old volcanic arc and we start the new one. So I want to put in here Siletzia, which of course was brought in from ocean plates, let's just say generic ocean plates, offshore. But you remember the timing of adding Siletzia between 51 and 49. It's right in our window. I don't think I'm saying anything new. Are we okay back there? Earth to Hayden. Are we doing okay back there? Thank you. I'll add one more thing. If you're a Baja, BC person, we're also adding more real estate into this area. After we kill, nope, get rid of it. Forget I said that. The main story is we're going to blame much of this jumping of the arc on the accretion of Siletzia. Now, why is jumping the arc, jumping the trench, jumping the arc, kind of the same thing, right? Trench position, 150 miles inland, arc. Now the present day trench position, 150 miles inland, the Cascade Arc. Why is it misleading for me to say jump the trench? Anybody reading my mind right now? I'm giving the impression, aren't I, with that phrase that this happened overnight? Like you kill this trench and you just move it immediately. You just kill this volcanic arc and you move it immediately. I'm not saying that. Here's the number 8. It's a slow motion jump. It's a 8 million year time span to go from our Idaho arc, volcanic arc set up with a trench, to our current Cascade volcanic arc. You following me? I'm trying to set the hook for today essentially, but also get us going from last time, and I think we're there. I can feel it in the room. We're there. It's an 8 million year transition time between one arc and the other arc. And what's happening during the transition time? The fricking Challis Magmas. Okay, so we have our bookends, our two volcanic arcs. We have our bookend in time, and that's setting the stage for our discussion. Now, let me go ahead. I am going to use colored chalk now. Oh boy. Oh boy. Am I bringing Challis Magmas just into the area between the two arcs? That would be nice and tidy just to do that. To say there's some sort of weird reorganization between one subduction zone and the next, and we just have these boils of magma coming up from below. But we know it's more than that. Yes. Yes. All the way back to the Dakotas. Yes. Up to BC. Yes. Unresolved part of the story sweeping down through Nevada. And yes, even some of the Challis Magmas are in the forearc on the west side of the Cascades. So even though we're kind of being nice and tidy time-wise with the Challis Magmas during that 8 million year span, geographically, it's not a tidy little spot on a map between the two arcs. You see my point now. Daddy's pleased with himself at the moment. He didn't even think he was going to do it that way. He likes it. Get off yourself. Do we have any questions? I don't think we do, except Matthew does.
You may be getting to this.
Yep.
But does the Farallon plate breaking, is that before, after, or at the same time of this?
We don't know that the Farallon plate broke yet. Oh my God, what just happened there? Did I have a stroke? What? Give me some food. Hey, Rachel? No, that's. COVID. Oh. And scene. We don't know about a broken plate yet, Matthew. That's our little secret. Okay? Good. So we're getting there. Pick up the pace, boy. What's your outline say? According to the geochem of the Challis Magmas, and this is where I'm going to have to punt part of this and go to the Zoom chat that I will post later this week with Jeff Tepper. He's got geochem saying that there is a mantle upwelling trigger for these Challis Magmas. Yeah, I'm being coy, Matthew. I'm being coy as hell. Sorry, Patrick. I want to build suspense even more. If you don't like the teasing part of this thing, today's not a good day. I'm still teasing. Mantle upwelling trigger. What does Tepper mean? And more importantly, what evidence does he have? That's the part that I struggle with. I asked a couple times and kind of got it, but not really. So a reminder, now that we know we're talking about the Challis Magmas, we've looked at evidence that these are not subduction magmas. Good. We looked for evidence last time, you got it in your notes, that these magmas are dry. Water is playing not a very large role in the formation of these Challis Magmas. We decided they were hotter generally than a subduction zone set of magmas. Because we don't have that water, we need the temperature to be hotter to generate melt. Good. And this one we did not get to. But this is the third and final calling card of Challis Magmas in pink on the map. They're generated deep in the crust. I'm slowing down. Sounds like I'm going to say a bunch of stuff that's really interesting. I'm not, because I don't understand it. But the statements that are going to work for us is that we have a boundary between the crust and the mantle. This is the moho, correct, from Geology 101. And our crust that's on the map is not typical continental crust generally. It's a bunch of accreted exotic terrains that have an oceanic story to them. Let's not dwell on that, because that's probably going to make our brains explode. At least mine it will. But Jeff's point is that this is important. We have, during Challis time, upwelling, upward flow of mantle. I'll just finish my thought, even though you're going to want data and I don't have it because I don't understand petrology well enough. The concept is we are making these Challis Magmas by triggering melting in the lower crust because of intense amount of mantle flow, shallower than it should be. I've said this casually a couple of times. I'm trying to do it graphically now. So what I want to do is kind of draw an ellipse here and say this is where we are creating our melts. And that's where my eyes glaze over. And some of you might know about eclogites and plagioclase feldspar being unstable at a certain depth. And I should know all that stuff. I just don't. So we'll rely on Jeff with the Zoom chat for that. But notice we're not melting. Sorry, we're not subducting here. Now this is a cartoonish cross section from the Snake River Plain, and it's almost a mistake to show this because the Snake River Plain is far younger and it's a mantle plume story in general, but I still want to show it to you because it's showing our pooling hot mantle at the base of the continental crust, and just the idea that we're generating some melts. Now, in this case, they're doing some mid-crustal melts in the Snake River Plain of southern Idaho. Can you bring this down and realize that this is a deeper story? I think I regret showing that to you. There's so many exceptions to that rule. But why am I doing it this way? Why aren't I getting to the fun stuff? Why don't I start talking about plates? Because whatever model we come up with, you and I, today and Thursday, we need this surging mantle, which is not a normal thing. It's a hot time, it's a hot zone, and tectonically, we need this to start 52 and we need it to end 44. It's not an ongoing thing. It's our specific chapter that we've been talking about. Oh boy, Ryan is really working. I can see it. The eyes are darting. You got your hand up. You want to say why. Am I going to shut you down here? I think I am. Go ahead. Thank you for that very disciplined question. Ryan says, does this mantle melting have anything to do with the accretion of silesia? It's during the time of accretion, during and immediately after. Remember, probably the last time we'll look at our board. I don't think I'm going to add anything here, but our entire list is the aftermath of accretion of silesia. So the short answer is yes. I don't want to be more specific than that necessarily, but especially on Thursday, we will be specific, and you'll see how the accretion of silesia is going to create, it's going to encourage mantle, release the mantle valves and send this stuff up. And we're underplating the crust. Again, I'm on thin ice here, but we're doing so much mantle surging that we're actually adding to the thickness of the crust here. There's a bunch of gabbro down here that we're actually pooling, heating, and forming a crust at the base, almost like it's burning on the stovetop, and we're just adding a crust at the bottom. So Jeff got into a little bit of estimated crustal thicknesses during Challis time versus now. I can't do it. Can't do it. But you're hearing my main message. Should I give you a couple more phrases that I furiously jotted down? Upwelling of the mantle triggers melting deep in the crust. This is decompression melting. You probably know more than I. What kind of rocks are we talking about that we're generating from this? We know it's diverse. We know it's the BADR, but we're into some specifics about calc-alkaline rocks. I don't know anything. There's some oceanic basalts being created at this time. Heard of it. S-type granites. I mean, we could break out and have some of you right out of petrology tell me all about that. I don't have time. I-type granites, A-type granites. What? Frickin' adakites, still struggling, but that's part of our story with strontium and yttrium. Okay, mantle-derived magmas provided heat to drive the mantle. Mantle drivers, now I'm just writing the same thing over and over again. That's a sign of confusion. Okay, we're moving. We're moving. We need a tectonic reason for this mantle upwelling. Well, isn't the first thought that you would have the Yellowstone Hot Spot? Why can't we just, do you need it? Why can't we just have all this pink generated, not from, we know it's not from subduction. We know it's not from subduction. So why can't we just bring our big blowtorch, our big flashlight, get it under here? We need mantle flow. We need hot mantle flowing to the base of the crust. Why wouldn't that work? It doesn't work. If you were ready to defend the Yellowstone mantle plume being beneath the entire Challis region, I'm going to shut you down. We're not even going to go back and forth about it. How can I prove it to you? There's two reasons. No, I'm going to involve you. What's one reason? We're trying to explain these, aren't we? 52 to 44. These are the Challis Magmas. Yeah, let me slow down. Let's involve a couple here. What's one argument against the Yellowstone mantle plume creating this set of magmas? Megan.
It's in the wrong order. It would have to be older to younger.
Thank you. I'll just do it verbally because I think this is pretty easy. Megan and others, I think, have it. We have the wrong age progression. We have the opposite age progression, do we not? We know about the lavas created by the Yellowstone Hot Spot across southern Idaho, and it goes 17 to today. That's going way back to the first couple weeks of our class. You remember all that. So we have an old to young age pattern with a drift, that we don't have to do this all again, with the southwestward moving North American plate over a stationary mantle plume, blah, 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 we would get this pattern. We got the opposite here. We're going younger to the southwest. Thank you, Megan. I don't need to beat that to death. Is there another reason, based on what we discussed in the first third of the class, that shuts down the Yellowstone mantle plume pretty good for this discussion? Kyle, want to try? That wasn't a hand up. Kyle's blindsided. Ariel.
The Yellowstone Hot Spot was offshore until after the accretion of flood. Until quite a bit after the
I'll take you and run with it a little bit. Thank you. I did put this down here. This is building Silesia. Give me those dates again. We're building Silesia between 56 and like 48, really. So we're, pretty close to Challis time. Maybe you're kind of saying this. We're still mainly offshore for much of this story. Doesn't work exactly, right? But I think that's Ariel's main point. We're offshore. And I will add to Ariel and say, unless I'm missing something, and it's possible, the Yellowstone mantle plume is fixed, and North America has been drifting, not a penis, just an arrow. In the simplest way to present this Yellowstone mantle plume is too far south. Let me say it a couple more ways. If it's as simple as the North American plate having the same vector generally to the southwest for the last 56 million years, it appears that the mantle plume is drifting to the northeast. Well, fine, we know it's not happening that way. It's us moving over the fixed mantle plume. But my point is, the passage of this Yellowstone mantle plume is a California story, is a southern Oregon, very southernmost Oregon, Nevada story. And of course, it's a southern Idaho story. Nobody at any point is talking about the Yellowstone mantle plume fucking cruising through here. Sorry, Patrick. Hayden does want to say something. Oh, it's Kyle. Hayden.
Is there any way to, if the yellow hot spot was moving itself to and not fully stationary?
Hayden's wondering about, is the mantle plume truly fixed or not? Is there a way to talk about a drifting mantle plume? That's all been worked out. It's beyond me, and I don't want to go there right now, but thank you. For our purposes, we're visualizing this as stable. Even if it's moving a little bit, I still think it's a southerly journey for this Yellowstone mantle plume, and therefore, all these crazy magmas in our state, I don't see how we can do it. Even if you want a regional head, even if you want, some sort of broad, 100-mile wide zone of heat or something, we're still too far south. So I want to move on, obviously, but we're not going to talk about the Yellowstone mantle plume at all the rest of the class. It's too far south, and the age pattern that we have for the Challis Magmas here in Washington, which is our main focus, is opposite, is wrong. You comfortable leaving? Yellowstone mantle plume's going away. Okay, what's next on the outline? I guess I should keep this. Okay, it's like, what's the game? Your friend's trying to find something like cold, frigid, super cold, ice cold. You're not looking in the right area. What's that called? I don't know. What do you normal people play? Okay, so we're ice cold with the Yellowstone mantle plume. We're not even close. The spreading ridge, subducting beneath the Pacific Northwest, we're getting warmer, literally and figuratively. Thank you. It's not Jeff's story on Thursday. It's not. He incorporates some subducting spreading ridge in his models. You'll have some beautiful color handouts on Thursday that beautifully lays out Jeff's, well, hell, if you can't wait, go to the 351 site. I got the papers there. It's all there in living color. You can't wait. But if you want to wait for most dramatic effect, there is some subducting spreading ridge story. But here's the main thing that I got excited about from my Zoom chat with Jeff yesterday. I didn't have this. And remember, he hasn't published anything with a paper yet. It's like this is student posters and something he's been working on, kind of coordinating for 20 years. So at one point I said, do you have these major groups coming at you, like the spreading ridge people coming at you and not agreeing with your tectonic model? He's like, well, I haven't written the paper yet. They don't even really know what I'm up to. Okay. So are we really going to do this? Kinda. Oh boy. That's a spreading ridge. Northeast, southwest. What do I mean? Are we going to do this again? Well, hell, you remember. Mike Eddy wants a southward migrating triple junction. Everybody else wants a northward migrating triple junction. We're not going that far yet. We might do it a little bit on Thursday. But let's just keep it here. Let's just keep our spreading ridge right here. Let's make it as simple as we can. What is this? The boundary between the Kula plate and the Farallon plate. And you know what? I'm going to change those arrows because I always get stuck with that. When you look carefully, at these ocean plate maps with these vectors, there's commonly multiple spreading ridges that are all contributing to the direction of a plate actually moving, like the Farallon. Like, what direction is this Kula plate moving on this map 60 million years ago? Like, we got 3 different vectors adding to the thing, So what I always get caught up on when I try to draw this simply on a chalkboard is I show our spreading ridge. Oh, I'll do it. And then I just put the arrows perpendicular to it. But again, if we have 2 or 3 other spreading ridges to the north and to the south of this, what I want, which is important, is the Kula kind of doing that. Even like this. The basic is, we know this is a spreading ridge between Kula and Farallon. Forget about the resurrection. It's too much to think about. But it's not coming head on. This is oblique subduction. There's an upcoming Penrose conference, hopefully, that will focus on this business about all sorts of geology related to an oblique subduction. Boy, that'll be a fun group. It's not head on. We can get some subduction, but we also have that right lateral offset, if you recall. That whole thing. Okay, this is more than I want. Let's just go ahead and have 2 ocean plates obliquely subducting beneath the west coast of North America. And most important, why not? Most important is our submarine spreading ridge subducting beneath the Pacific Northwest during Challis time. Am I going to call on you, Ryan? Yes, I am. Can't see the chalkboard. Thank you. So, brownie points if you have this with you today. If not, I think you have a sense of it. I've given it to you actually in 2 forms. Way back, I gave you Dave Tucker from Western Washington, giving us a very colorful version, and he has an east-west spreading ridge subducting. Most everybody else doesn't want an east-west spreading subduction. I'm not even sure it's worth digging for. This one, I just want to get the point across. Remember that when we have a spreading ridge offshore, do you want to do it? We can do it like that, I guess. So I'm trying to show you obliquely here that we have a spreading ridge that is subducting as well as 2 ocean plates. And we're trying to decide, is a subducting spreading ridge the reason for these hot, dry, deep, non-subduction Challis Magmas? We're all there. I can feel it. And the concept is that when you subduct the spreading ridge, we did this quickly, but I want to do it more carefully now, you develop a gap. You develop a place under the continent that doesn't have an oceanic plate. And you're like, why not? It's because you're subducting the fricking ridge. The ridge is where we're actually, the ridge is where we have mantle upwelling. Oh, this is promising. If we're subducting something that's already upwelling mantle, and we send this divergent plate boundary under, let me finish, Rachel, and then I'll come to you. Maybe we're doing a bunch of upwelling of mantle, say the researchers, underneath the Challis Magmas at a time that we're subducting this spreading ridge. The point is, last point, and then I'll open up to you guys just to see where we are. Notice that this slab window, as it's called, not a hard concept, the slab window is getting wider and wider as we go further in time. Is that the right way to say it? I think so. As we continue to subduct a spreading ridge, our gap widens. And so I tried to hint at that here. Now we're getting our diffuse magmas getting wider and wider as we go inland, again, because we're subducting these two plates. I'm fully engaged now, baby. And this is looking damn promising. And I'll give you a hint. I don't want to build up the Zoom chat too much, but I encourage you to watch it after this one. Jeff said, when I started working on these Eocene magmas 20 years ago, first of all, I didn't even know about the Challis Magmas. And he went to UW. But second of all, he just assumed that the Challis Magmas were from this story. And after doing his 20 years of painstaking work with his students, he found data that argues against this being the sole reason for the Challis Magmas. Now I involve you. Do you still have yours, Rachel?
Yes. I am not understanding how the dates go from 44 to 52 if the American plate is still moving to the, okay, so you're picking up what I'm.
That's where we're going there next. Rachel wants to go there. Let's do it. Rachel says, I don't understand why you would have 52 to 44. This is the data we have. Not published in a paper, but published in these student posters. The data we have is an age sweep this way. Let's write it. Northeast to southwest, is it not? The actual Challis magma age progression, hold on, Tim. The age progression we have is northeast to southwest. And Rachel's like, I don't see how that supports a slab window. And I'll cut to it. When Jeff found this age pattern after more than a decade of work, he realized that the slab window is not the main story. So if you remember, I set up our discussion today as a table setting for Thursday. This is not the answer. It's a portion of the answer, but it's not the main answer. And you know what? I'm going to spitball off of that. Jeff and Mike Eddy and a few others were working with the tentative idea that all the Challis magmas were from subducting a spreading ridge. What age pattern would you expect to find with these Eocene magmas? Like, I don't know about the opposite. Well, maybe. Go ahead.
I don't know if this is quite good too, but if we go back to Eddie a little bit,
Yeah.
the ridge is coming, North America coming this way, it's
Right.
like the ridge is moving.
Right.
Right. So you almost see like a north-south.
Yes.
Kind of age.
Thank you, Tim. And I know a couple others have your hand up and you want to do that too. Let me try to be as firm as I can with a couple statements and then we'll go back to you, okay? This is a northwest to southeast younging of the Challis magmas. Jeff and others were expecting to see some kind of a margin parallel age progression. If this is truly a slab window subduction or a slab spreading ridge subduction making a slab window, they would expect younging to the north or younging to the south as you widen this thing, or maybe the opposite. Maybe you can argue for younging. Oh, let's do it. Old to young, or old to young the opposite way. And you're like, what is this guy doing? Like, I haven't thought about it that much. Maybe you'd expect it youngest in the middle, and then it would just get older and older and older in both directions. Or maybe if we're doing this strike slip faulting, you remember the whole Alaska thing with the near trench magmas? I know this is advanced now, but just hear me out. Nah. Here's my firm statement. Mike and colleagues were expecting some sort of north-south age trend. Take your pick. Young to old, old to young, young in the middle, getting older and older. I don't care. They just expected this kind of a northwest-southeast age pattern, and they found exactly perpendicular to that. Wrong. Totally wrong. Okay, let's open it. Hayden, engaged today.
So with this, is there the effect of the clockwise rotation on them? Do you see that? Is this corrected, or do we still have to put that into account?
Thank you, Hayden. Hayden's wondering about clockwise rotation, and do we need to undo the clockwise rotation? We do. Please remember that our whole Silesia bedrock was originally down here and has been rotated away from its original position. I don't know, maybe you were puzzled that I removed the Yellowstone Hot Spot so quickly from our discussion, but we do know that the clockwise rotation has happened 1 degree of rotation every million years for the last 50 million years. And so you're right, Hayden, we do need to backtrack and get some of that other stuff out of there. And I don't know if I can handle that at the moment, but I assume that, yes, we need to get it out of there. And yet we still have, one last thing to say about that. The rotation is almost nothing this far east. So once we get so far out to Western Washington, Western Oregon, we don't have most of our Challis Magmas. So yeah, we might undo some of the rotation to restore to Eocene time, but I'm not sure we're a whole lot different time-wise. Good thinking though. Megan.
Didn't our rotation start not quite that far back though, because it has to do with where the plates are currently sitting is why we're rotating?
If we go back to Wells, he's got the rotation, the clockwise rotation beginning at Silesia accretion time, 50 million years ago. So that far back.
Okay.
Yeah.
So kind of in the middle of when these happened then.
The rotation is beginning during our story, or second half of our story. But I don't know if I can juggle that one. There's too much to juggle at the moment. Rachel.
So I was thinking this is probably really far out.
Go ahead.
Depending on like how many zircons he tests.
Yes.
For the 52 and 44.
Right.
Could that spreading ridge melt some of the crust that's already there and then throw the dates off? So like you would have older, like new to the right and then younger to the left.
Rachel and others are kind of thinking about what age pattern they really would expect. And depending on how many zircons we're collecting and maybe some re-melting and crystallizing again, I'm not, even, it's last week of the class, I'm still not going to deal with adikites much. I'm still mostly confused by them. But what I do know is that the adikites are forming when we have an extra hot piece of ocean plate down below us. And the adikites are telling us we're at the edge. We're at the edge of something like this, like a slab window. So I'm still working on that, but the adikites do fit into this story because we potentially, let's say we have our slab window. Let's do it. Let's just make up a slab window right here. This is an open gap in between these two lines. So this is plate underground, this is plate underground, this is an edge of a plate underground, this is an edge of a plate underground, this is open gap where we can have hot mantle coming to the surface. And so what many of the researchers are saying is that our atakites are forming kind of we're nibbling at the edges. We're nibbling at the edges of these underground subducting plates, and eclogites are part of the story. Don't ask. Don't ask. We got 3 minutes left. We're going to Ryan, and then I'm taking us to the last part of the lecture. Ryan,
So this might be a bit out there.
go ahead.
But is there any possibility that once the spreading ridge is subducted out of the continent,
Yep.
the plates on either side are still moving, that might have
I love the last two sentences. I'm going to focus on that. Ryan is working with the idea that we have crustal extension during this time. This Challis window, I don't have the board handy. You remember, I should go to it. Not only are we going from not only going from Idaho Arc to Cascade Arc and 8 million years in between, remember, we're going from crust squeezed to crust extended to crust squeezed again. So yes, I didn't catch the first half, Ryan. I'm not going to double back now, but maybe after class. This is an extensional story. Okay, you're going to give me 3 minutes, whether you want to or not. Your handout today looks like this. And we're finally ready to talk about Tepper's model. I'm not going to reveal it yet, but let's look at these colors. You've got it, so I'm going to come in tight for the home crowd. This is from one of the papers listed on the 351 website. It doesn't have a star. You're not responsible, but I encourage you to look at it. This came out 10 years ago. Gene Humphreys at University of Oregon. What are we looking at? A map of the Pacific Northwest, Washington, Oregon, Idaho. A cross-section of the same area. So this heavy black line through the map, you've got it, is what's underneath here. Everything underneath the heavy black line is in cross-section. Blue is dense material. Blue is ocean plate material that is in the subsurface, a la Karen Siglock. Look at the depths. These are in kilometers. We're not between the 1,000 and 2,000 kilometer depth of the ribbon candy and all that. That's way too old a story. But we're still quite a ways down. What is this? It's the subducting Juan de Fuca plate today, otherwise known as the Farallon. What in the F is this? Which is the same as this boomerang on the map. Humphreys called it a slab curtain. It's a piece of ocean plate that's hanging vertically underneath the great state of Idaho. This has to be more than a simple spreading ridge subduction story. Because this frickin' thing on our map, different color, is sitting here like this. It's vertical. It's not at the surface, it's in the subsurface, but the geophysics, the seismic tomography tells us that right across what should be an open slab window is a hanging plate. And how are we going to explain that? We're going to break the plate. We're going to break the plate, dog, twice. We're going to break the plate twice. Call back, Megan. Give me a break. Give me a break. Break me off a piece of that Farallon, possibly Kula plate. And again, thank you. I love you. We'll see you on Thursday for the thrilling conclusion of Challis Magmas. Goodbye. Thank you for joining us. I can tell people want to talk for a long time, so it's going to be a longer wait than normal. Hold it. This says my connection is unstable. Please wait while we try reconnecting. Am I still here? I'll be with you in a sec. Can I ask you, there's a delay in the comments. Yes or no? Are we functional here? Why do I get this message that my connection is a problem? Yes or no? Are we good right now? I'll get to you, Rachel. Okay. I know you want to talk. It's probably 10 minutes. You're going to have to wait. Okay? If you want to talk about this stuff, let's do it right here. Come on over.
Okay, quick question.
Yep.
So this paper's from 1993, but I read that little excerpt. Is that what you're talking about?
Second tectonic model, origin of the KI. Caledonia. Decompression, crustal thickening, age of telescoping and metamorphism.
I know we're kind of scrapping.
So is that kind of similar?
I guess there's key words there that work for us,
Yeah.
but I don't understand.
Or I don't know if it-
Obviously, we're in a different part of the world, right?
Yeah, yeah.
Okay. Generally, yes.
Okay.
And you know about K-type magmas or I-type
They're
granites?
calc-alkali magmas is what I'm.
Okay, yeah.
But I don't know
I
the
guess the
difference
answer is
between
yes.
the
No, I don't know.
Okay.
Yeah, good. Matthew?
I'm trying to get this all organized in my head.
Yeah, baby.
Very last thing you said, broke it off twice.
Broke it off twice.
Right, and I'm looking at my notes from earlier this quarter.
Yep.
So first break off caused that slab jump, right? Maybe not.
The jump of the trench is happening as a result of the breaking.
The first break.
Mm,
Okay. So this is why I'm asking.
okay.
So I think the second break
Yeah.
that it looks like I have in my notes that I was from 17 to about 15,
Yeah.
the flare up of the CRBG.
Oh, I'm sorry. You're way back there. Okay.
Yeah, so I'm trying to like connect everything we've talked
I
about
love
so
it.
far,
I love
and
it.
I really am struggling to do that.
Give yourself a break for, listen to that. Oh, what a pun. Give yourself a break. Okay. I love what you're trying to do. You're trying to take stuff from the first third of the class and apply it here. Were we talking about adakites back then? Yes. Were we talking about breaking a plate? Yes, we were.
Different story.
Different story because that was our friend, the mantle plume, burning a hole through that frickin' thing.
Okay.
And,
That
that's
makes sense.
part of the reason we're removing the Yellowstone mantle plume from us now. We're much older now and too far north for that. So we're going to break it for a different reason
Okay.
twice. But the adakites tell us about a break. And a new wrinkle is going to be this rolling back of a plate that gets broken off. But let's wait till Thursday on that.
Okay, and I'm sure the now that I think the models on Thursday, I feel like will probably help.
You will sleep like a baby Thursday night. Who knows how you'll sleep between
Awesome.
now and then.
Hey, thank you so much.
Thank you, Matthew.
Nick, what I was trying to get at with the extensional thing
Yeah.
is we're subducting the spreading ridge, right?
Let's do it.
So
Come on up, you guys.
if this is moving underneath and these two plates are also moving underneath, is it conceivable to think that as they're underneath the continent, there's still some motion this direction?
I guess so.
So could that be like, I guess I'd have to know like which, is there like a general trend of the crustal extension that we can, because I still don't understand how that's taking place exactly, right?
Well, so if we, I don't know the answer. So if we want to get a sense of the direction, the two main directions of extension, we would go to those core complexes that I mentioned quickly last time,
Right.
or last week.
Right.
And it's like, do all those core, is the kettle thing and the whatever thing and the pioneers, do they all have a northwest, southeast extension direction?
Right.
Are there normal faults that are separate from core complexes that are from this time? I guess that's been mapped. I don't know what the answer is.
Right.
But from what I understand so far, it's generally a relaxed story. We don't have two major plates hitting head on or even subducting obliquely. This is kind of
Because
no
we have the
man's
spreading
land.
center
because
so
the spreading
okay,
center
okay.
is there. So whether there's actual lithospheric material that's moving away, I'm not sure that's the point. It's just not being
It could even
compressed.
just, yeah, it could even just be that there isn't the compression going on.
Yes.
So the crust is, this is kind of like what happens with the earthquakes offshore.
Yes.
Okay.
And the model on Thursday will have, well, I already said it. We're going to break a plate twice
Mhm.
and get away from this general story. And the breaking is going to be like this. So the extension is going to be northeast, southwest.
Okay.
And so that, I guess, generally argues against this being the main story.
But that could be the source of a lot of the actual heat for the melting.
It could be, but again, his model is involving a little bit of subducting spreading ridge, but he's got a totally different model that's going to kind of stand alone.
Okay.
And if you can't wait, just go to the 351 page and do it.
Might have to.
Hayden's got a colored page. Hayden, what did you eat this morning?
Nothing.
Stick with it. Starve yourself. That's good.
Um,
Sweating through my scarf. Go ahead.
with this, with the rotation, the magmas are going opposite the rotation, which is one thing of its own, but they'd probably be pointed farther south, which would even be more against the hot spot. But also, question, why is this dense part here down in the southern part? There's that dense spot down there on the southern part of Oregon. It's nothing subducting anymore.
I don't know. So first comment is I was kind of brushing you off of the rotation because it muddies this so much that I don't know why we want to try to factor in that rotation right now. So that's my statement there. Yeah, our big boomerang of subducted slab is fine. Now you've already labeled this other one, the current slab, correct. And then you're wondering why do we have some dense stuff underneath the western, the north coast of Oregon. I don't know. There's not much, it doesn't show up on the cross section, but it just shows up on that map. I don't know. Very good. Bryce?
I guess I had two quick questions.
Attaboy.
Am I just going crazy? Was the original plan for the final exam Tuesday, or has it been Thursday?
It was a mistake for me to put it on Tuesday on Google Calendar early in the quarter, and then I carefully read the final exam schedule, and it's Thursday. Does that screw you up?
Well, I was planning on going home earlier, but that's fine.
Well, let's talk about it.
Right now, or
If you want to take the final on Tuesday, we'll take it on Tuesday.
okay. I was
Maybe we'll ask everybody if they want to take it on
I was
Tuesday.
just hoping to get home earlier, so that kind of just sets me back by a whole
So you can work at the grocery store a couple extra days.
No, but I could be home.
Make up something on the spot that's really appealing, and then I'll work with you.
My family is in really big need of me. I have to go back to the family ranch, the animals need me.
That's good. You need to family first. That's what I always say, Bryce. So we'll take the final exam on Tuesday.
Okay. Second question.
Yeah.
You mentioned that there are Challis Magmas
Yes,
further east.
right.
How does that relate to this story? Because if this slab, if you don't mind me getting,
Go ahead.
I'm fully vaccinated now. If this is like this regional story, we have stuff way over there. Like,
It's an argument against a simple spreading ridge subducting, isn't it?
yeah, it just like that seems like that could fuel this story. But how are they grouping those magmas as Challis Magmas? Are they similar in composition? Or the same?
They're all diverse, like the arc rocks are diverse. Some of the geochem details that Jeff had are uniform throughout. It's the age window. And his model is going to do a nice job of helping us at least understand why we have stuff coming up here in Montana. It's a stretch to go that far back to the Dakotas, but
Is it a clear line almost back to the Dakotas? Because you mentioned it's in the Dakotas, but does that mean there's like multiple instances, or is there like one or two, and then we don't know?
Jeff and others confess ignorance when we get this far east. We know Washington rocks barely and nothing over here, but there are other geologists who've been publishing and are kind of available by email to help piece this story together. But much of what you want to ask right now about back here don't have.
Yeah, no, I mean,
Okay, all right, thank you, Bryce. Ben is here. Please, please, who else? Absolutely. Absolutely, take them all.
You know, when you
Kyle?
blindsided me in class, I was actually preparing to say something about the location, that the location didn't match with the Yellowstone Hot Spot. And when you asked me the other piece of evidence why the progressive age,
I knew it, Kyle. I knew you had it in you.
yeah, it was just so fast. Like, yeah.
I got you, baby. All right. Uppercase, please. Let's answer some questions. Thank you for waiting around. And I might as well give you some tips for what's happening on Thursday. I'm sure you'll want to go there. Godiva, Demos, is it possible the resurrection plate is part of this? It is possible. If this is the resurrection plate and not the Kula plate, I'm not sure it matters for Jeff's breakoff model on Thursday. In fact, now that I think about it, I think Jeff Tepper likes the resurrection plate existing. But as I understand it, regardless if it's technically the Kula or the resurrection, I don't, all we need is an ocean plate to the north with this model on Thursday. Thank you. Oscar, to help visualize what is happening, where was the coast and spreading ridge 52 million years ago? Okay. Well, there's debate. Oscar, there's debate, remember. I'll remind you quickly of the debate. I think you remember the debate about the position of the spreading ridge. If you're a Baja BC person or many other groups, that spreading ridge is down in California 70 million years ago. It's up here 60 million years ago. It's 55. And you were asking about 52. So maybe 52, the spreading ridge is here. And then when we're in the 40s, we're up here. Jeff Tepper needs that spreading ridge down here in the 40s because of the Leavenworth fault and the Eniot fault and the rest of those guys having right lateral offset. So I don't know if that exact position of the spreading ridge is a big deal for you, Oscar, at 52. I guess you're picking the beginning of the trend, aren't you? So I see why that's an interesting part of it. I've never thought of that. Interesting, Oscar. I guess I'll just leave it like that. There's debate about where that spreading ridge, where that triple junction was 52 million years ago when we begin this sweep. When you see this Farallon plate rollback story, I don't think the position of the spreading ridge at 52 is going to matter a whole lot. But you'll see some beautiful block diagrams from Jeff's new poster. New meaning 3 years ago. Pat Miller, so is the docking of Silesia as much a result of the tectonics as it a cause? Result of the tectonics as it is a cause. Well, of course, Silesia is the result of a mantle plume building a large igneous province offshore. I guess you could say it's a result of tectonics that way. But as we'll see on Thursday, it's no accident that we bring in this incredible large igneous province, and at roughly the same time, we shatter the ocean plates in the neighborhood. I've never thought of it specifically like that, but I'll run with that a little bit. We're going to bust up the Farallon plate or the Kula plate. Okay, now, okay. Well, in some papers, they talk about the Farallon plate breaking. Tepper is careful to say that it's the Kula plate that's breaking, as we'll see. And that slab curtain, Jeff Tepper thinks the slab curtain is the Kula and not the Farallon. And of course, that debate is not that there's an ocean plate that's hanging vertically, but again, we're back to your question. Where was the plate boundary offshore during that time? still not too hung up on the difference, and instead wanted to focus on evidence we need for those two breaks. And actually, you know what? Let me see if I'm heading up to First Creek here. Hang on just a sec. You guys remember Andrew Sadowski, the guy that I was up? Andrew's up with this miner. Still planning on being up at the claim to meet you. Let us know when you leave, and we'll find an easy spot on the way to meet you. Okay. Well. So we'll do a little more live Q&A, and then I guess I'm hitting the road, going up to look at a Ellensburg blue claim. Let me scroll back. I hope you enjoyed today. Maybe it went okay. Chris, did Jeff or others find eclogites in the Challis Magmas? Yes and no. I guess since I'm busy the rest of today, I'm not going to post that Tepper Zoom chat until maybe Thursday morning or something, maybe later than that. Yeah, it's kind of intense right now. But that's the part that I got lost on a little bit. Jeff says eclogites are not stable at the surface, so you don't exactly just find eclogites all over the ground when you're hiking, but there is great evidence that the eclogites are a major rock type in the lower mantle. And then they convert to basalt or something as they get shallower. So you're on it, Chris. Eclogites are part of the story, but I don't think it's accurate just to say eclogites are found in the Challis Magmas, because they're not stable up here. Is the Idaho Blue Boomerang the old trench that died 52 million years ago? No. I think I'll find different ways between now and Thursday. Do I have any time to think about this? I guess I do, Thursday morning. I'll try to make this very clear, but you're looking down at this slab curtain that's hanging in the subsurface, and here it is. And this is the plate that went down the trench. It went down the subduction zone. Did you ask, is it the trench? Yeah, it's, I don't know if you can think of it as an old trench. You can think of it as the ocean plate that went down at the trench. But technically, it's an ocean slab. Adikites, I got to punt on adikites, except to say that adikites at the surface are an indication that there's hotter than normal ocean plate material in the subsurface, and you're melting the edge of that ocean plate under the surface, and you're like dealing with the eclogite somehow. But beyond that, I don't know how to include those adikites. Could you compare adikites? Sorry, I got nothing for you beyond that. Frank, Challis Magmas all the way east to blank. Does the age trend persist? Any dates older than 52? Jeff mentions that he is not aware of the details of the Challis Magmas further east than Idaho, let's say. He's not aware of the details up in BC. He's not aware of the details in Nevada. So maybe Jeff Tepper is not committing to anything necessarily, even though he just retired. I don't know, why not? But if this gets established and he publishes a paper on the Challis Magmas in Washington, I guess the next step, if he wants to keep rolling, is to keep expanding. I was just reading a road log written by one of my former professors, Paul Link. I went to grad school in Pocatello, and some of those places he was talking about up by Challis, I haven't thought about in 35 years. But like, I almost thought, like, why doesn't Jeff Tepper go here and go to actual Challis, Idaho, and sample some of that if it hasn't been sampled to the level of geochem detail and high precision lead uranium dates or uranium lead dates from the zircons. I don't know, has that been done down here? If it has, then why doesn't he just keep repeating the process all the way back to the Dakotas? That's easy for me to say. But to answer your question, Frank, I'm pretty confident none of this extends, obviously, as we currently understand it, beyond Washington. Regine, is it always the same spreading ridge, or were there several of them? I guess there's an argument for two of them. In the Zoom chat that I'll eventually post, I remember Jeff did this. He's like, well, I'm ahead of myself now, but on Thursday we're going to talk about, I'll give part of Thursday away. Mute this if you want to be in suspense, okay? Here's a spoiler for Thursday. Sometime greater than 52 million years ago, we're going to take a subducting ocean plate and we're going to rupture it. We're going to break it. And in the subsurface, it's going to roll back. It's going to slump. And as it rolls back, or as that broken off ocean plate, most say the Farallon, Jeff says the Kula, as that rolls back, there's all this hot mantle coming to the surface and creating this pattern by rolling this thing back. But during the rollback, it breaks again. So he says, think of it this way, Nick. Think of it as a portion of an oceanic plate rolling back, but to the north and to the south, keep some ocean material. If this is I'm thinking about this right now. You can help me write Thursday's lecture in real time here. If this hook 'em horns thing is the Kula, then he's rolling back the Kula, but he's keeping the Farallon subducting beneath California, and he's keeping the Resurrection subducting beneath BC, possibly. And he says there's a tear, you need a tear on both sides, and that's where the adicates are. There's a small chance that's correct. All the Danishes are gone. The grad students and some staff members came down and cleaned us out. That's great. I've been eating too much lately anyway. 3 more, and then I got to hit the road. Appreciate you sticking around. I sure am bothered by this message I've never had before. Your connection is unstable. Please wait while we try reconnecting. But you're all here, so hopefully we're okay. Is the boomerang shape a result of 2 subducted plates pulling apart? I don't know, Steve. Good question. Papagino, does the Rocky Mountain Trench fit into this story? Possibly. I've never learned much about the Rocky Mountain Trench. We're getting into Rocky Mountain geology now, which is generally an older story, but what do I know? Oh my God, we got Patrick. Patrick, age 7, when a plate subducts and a slab breaks off, does it move with the continent as the continent drifts? Does it breaking off equal bigger opening than just the spreading ridge? Thanks for the question, Patrick. I don't know if it makes a bigger gap than a spreading ridge, Patrick. Interesting question. I'll have to think about that. And does the slab break off and then move with the continent as the continent drifts? I don't think so. But I'll think about it. I'm not sure. Thanks for the question, Patrick, age 7. From Nick, age 58. 2 more. Did slab curtain cause upwelling for Challis? I would think of the opposite. And this will be expanded on Thursday. Thank you for the question, Richard. I'll, if I'm worth anything, I can do some drawing on the board on Thursday to help you see how the slab breakage and rollback allows us to send a bunch of hot mantle to the surface. But I would think of the slab curtain as the opposite. The slab curtain is not where we have Challis magmas, but this gap between one piece of ocean plate and another piece of ocean plate, that's a gap that's actually going to allow us to get stuff from beneath the plate to the surface. That's kind of the whole point. Thanks for the question. What did I say? 2 more? John, is a slab retreat another option explaining the southwesterly trend magma event? Slab retreat. I don't know if slab retreat is the same as slab rollback, John. I'm guessing it's not based on the way you asked your question. But slab rollback is truly just this wilting of the ocean plate between 52 and 44 million years. And if you look at that drooping or wilting or rollback, I don't like rollback. I know that's traditionally said, but I want to find something else that's a little bit more descriptive of this. As you look at that rollback from above, I don't know, is that your slab retreat? I mean, we're still bringing plate material in. We're just rolling it back because it broke off from the rest of the Farallon that presumably is further inland. One more, down here to live. Peter, when 2 cars crash, they bounce apart. Did Silesia bounce? I don't think there's any evidence for a bouncing back, mainly from I think we have to go back to Mike Eddy's evidence in the SWAC, where he had an upland as a result of the accretion. Part of Silesia actually emerged from the ocean. It was significantly deformed crust inland of the suture point. I can't think of any evidence to suggest that there was kind of a bouncing back. Thank you. A toast to you. Here's to your health. Here's to the health of your friends and your relatives who you may or may not have seen this past weekend. Yesterday was a holiday here in the States, so we're coming off of a 3-day weekend, and always feels like a Monday, but it's a Tuesday. So here's to family and friends and their good health. Here's to your drive to continue to learn and your loyalty for being with us here to the bitter end. I've been live streaming from this classroom pretty regularly since early January. And as I mentioned at the top of the broadcast here, I'm going to continue to make videos. Probably will be doing some live streaming in the future, but I'm not sure from this classroom. So this is the last week here in this big auditorium, probably for a while. So here's to you. Okay, I got to pack this stuff up as usual. I got to get home, pet Bijou the cat, grab some ice water and a jar full of peanuts, and head north up and over Table Mountain and visit some geologists who are up there waiting for me. I don't think I'll film, but who knows? Maybe I will. So thank you. I love you. And we'll see you on Thursday for our conclusion to the Geology 351 classes. Goodbye from Ellensburg, Washington, USA.